These two graphs are quadratic functions. You can tell because there's an x squared term. The first one, number 2, is already in work form, so that's easy to graph. So we know that a parabola, first of all, normally goes through 0, 0, 1, 1, 2, 4. So this is like the y equals x squared graph, just y equals x squared. We call that the parent function. And then after that, we can translate things or transform things by adding or subtracting within the function or outside the function or multiplying. So in number 2 here, what's inside the parentheses before we square it moves it left or right. So this is going to move it left 2. It moves it to the x value. That makes what's inside the parentheses 0. So that's -2. And then this one moves it down 4. That -4 moves it down 4. So left 2, down 4. So that's where our vertex is going to be. And we can still think of those same values. You can make a table if you need to, but just in the normal parabola, we learned that you can go over 1, up 1 squared, thinking of a parabola or a term squared. So over 1, up 1 squared. 1 squared is just 1. Over 2, up 2 squared. 2 squared is 4, so over 2, up 4. And since a parabola is symmetric, you'll have some corresponding parts on the other side of the parabola. And then we can graph this parabola. A couple things about the parabola. The domain is the real numbers, and the range is y is greater than or equal to this y value here, so -4. All right, so that one was already in work form, nice and easy to graph. This next one is not in work form, but we are going to put it in work form. So let's look at this. I'm actually going to rewrite it over here. F of x equals -2x squared plus 4x minus 6. And what we do is we factor out whatever this value is out of the terms that have an x in it. So we're going to factor -2 out of the first term, so that's left with x squared. And then factor in a -2 out of 4 gives us -2x. And this -6 just stays outside. We don't factor a -2 out of that. Now what we do is we take half of this linear term, which is -1. We take that -1 and we add it squared inside these parentheses. When I say these parentheses, I mean these thicker ones that I'm doing right here. So we take half of -2, which is -1, and square it and add it in there. So we just added 1 in there, but actually, as you look outside here, this 1 is multiplied by -2. So we actually added -2. So in order to keep this balanced, we have to add 2. So in reality, we added 0 to the right side of this function. And now that we've completed the square, we can write it as -2 x minus 1 squared minus 4. Now it's in this work form, so we can graph it. We know that the parabola is moved right 1 and down 4. Right 1, down 4. Now this -2 tells us it's going to be opening downward because it's negative. And it's going to be steeper because it's a 2. Now the way we can think through that is normally with the parent function of the parabola, we could go over 1 up 1 squared, or over 1 up 1. Well, we would go over 1 up 1, but that 1 is multiplied by a -2, so we actually go over 1 down 2. And if we think go over 2, 2 squared is 4. We would go over 2 up 4, but that 4 is multiplied by the -2. So we go down 8. So over 2, down 8. So 8 units, not just to -8, so going down 8 units takes us to -12. And since this is a parabola and it's symmetric, we have some corresponding points on the other side of the axis of symmetry. And there is the graph of the function. Now another thing you can do once you get the vertex, you could plug in, you could make a little table and plug in values close to 1. So you could have plugged in 2 and 3, plugged it into this function and found those points. But there's the graph of the function.